Fantastic. All right. So, just like you heard in that brief intro, I'm going to be talking today about how to master diabetes using a low-fat, plant-based whole food lifestyle. And before I get too deep into the presentation, I'd like to say one thing here, which is that even though this presentation talks specifically about diabetes as well as blood glucose control in general, this message also applies to people who are not living with any form of diabetes and people who are at risk for the development of pre-diabetes and type 2 diabetes. So if you're thinking to yourself like, oh, this doesn't pertain to me, then I urge you to keep an open mind, because a lot of the sort of biological mechanisms which we'll cover today happen in non-diabetic individuals and can progress to frank pre-diabetes and type 2 diabetes over the course of time. So what we'll cover today basically are four specific topics. The first one is, what are the dietary causes of insulin resistance? And the reason why I'd like to go into detail about this is because on the internet today, there is a lot of confusion about what causes insulin resistance and what the actual mechanism of insulin resistance is. Whether you go to Instagram or YouTube or TikTok or read a blog or WebMD or Google, it seems like the world of insulin resistance has gotten, unfortunately, overly complicated. And my goal is to try and make it much simpler and clear up a lot of the confusion so that you can walk away from this presentation having a really good idea of what aspects of your diet can contribute to the development of insulin resistance, and specifically how insulin resistance can unfold inside of blood vessels, inside of your liver, and inside of your muscle simultaneously. So that takes care of number one and number two, both the causes as well as the biological mechanism. The third thing I want to talk about is what is considered double diabetes. And this is a concept that has actually been written about in the medical research for over 30 years, but I don't see very many people talking about it. And I'd like to sort of introduce the concept and give you guys a little bit of an idea as to what it is and how it can be created. And then after I tell you the doomsday scenarios, I will then go into how you can actually solve this problem using your food as medicine, using a plant-based diet that is specifically engineered to be low fat and whole food. So before we go too far, I'll just tell you my quick story. I was diagnosed with not with one, not with two, but with three autoimmune conditions in my senior year of college. So the year was 2002. I was graduating from Stanford University, and I was just trying to move on with my life. I was studying mechanical engineering at the time, and I started to feel pretty low energy, and I didn't understand why. I recognized that when I got up in the morning, it was very hard for me to start my day, and I'm a pretty energetic guy in general, and it felt like it took all the energy in the world for me to put my feet on the ground, for me to get out of bed, for me to brush my teeth, and for me to just start moving. In addition to that, I also recognized that I was unbelievably thirsty, like thirst I had never experienced before. And I've been an athlete my entire life. And I thought I knew what thirst was, but I actually didn't until I went through this episode. And it felt to me like every time I drank a glass of water and put it down, then I got thirstier 5 minutes later. So it was this like very challenging scenario where I would drink water, and then I would drink more water, and then I would drink more water. And every time I added liquid into my mouth, it felt like I was getting thirstier and thirstier and thirstier. So I picked up the phone to call my sister, and she told me right off the bat, she said, stop everything you're doing. You are explaining the symptomology of type 1 diabetes. Please go to the health center right now. So I listened to her advice. I went to the health center. While I was there, they transferred me directly to the ER in the hospital. And there they diagnosed me with 1, 2, 3 autoimmune conditions. Hashimoto's hypothyroidism was the first one, which is a autoimmune disease that attacks your thyroid gland and decreases your thyroid hormone output, which is very important. Number 2, alopecia universalis, which is, as you can see on the picture, this is basically scientific jargon for doesn't grow hair. I used to have a full head of hair. I used to be able to grow a mustache. I used to have ear hair, nose hair, eyebrows, eyelashes, chest hair, armpit hair. I had hair in many different places in my body. Alopecia universalis is a condition which attacks the hair follicles everywhere in your body and basically makes it so that you produce zero hair. And that is as the second autoimmune condition. The third autoimmune condition is type 1 diabetes, just like my sister had told me. And as a result of that, I went into I was diagnosed with with what was called a polyglandular autoimmune condition. And all of this unfolded in a very short period of time. Now, my medical team at the hospital said, we've never seen anything like this before. You have what's called a PAS, a polyglandular autoimmune syndrome. And that means that you have multiple autoimmune conditions, each of which are attacking different glands inside of your body. We don't know the cause. We don't know why it happens. And to be perfectly honest, we don't exactly know what to do about it. We can, however, tell you that if you want to lower, or if you want to keep your use of insulin low, because you are going to now have to inject insulin for the rest of your life, that the best way to do that is to try and avoid eating anything that contains carbohydrates. So I'm 22 years old. I don't know the first thing about carbohydrates and fat and protein. I'm sort of vaguely aware of these concepts, but I don't really know that much about it. And so they kind of gave me this crash course education and said, the foods that contain carbohydrates are things like breads and cereals and pastas and cookies and crackers and chips and sodas. And then also fruits and potatoes and rice and corn and, high carbohydrate rich foods that come from the natural world. So they said, you want to try and avoid as many of those foods as possible, because carbohydrates you can pretend like you are basically allergic to carbohydrates. And instead of eating those foods, you should eat foods that you see on the screen right here: meat, red meat, white meat, fish, dairy products like butter and milk and cheese, as well as eggs, and processed meats like bacon. But I want you to limit your intake of carbohydrates. So if you're going to have a little bit of bread, then that's okay, but just have a couple of pieces and try and get most of your energy from fat and protein rich sources. I'm a 22-year-old guy. I'm an athlete. I said, okay, great. I already like eating meat. You're telling me to eat more meat. Sounds like a pretty reasonable prescription. Fine, I'll do it. But the problem was that no matter how hard I tried to follow their prescription and avoid carbohydrate rich foods and eat protein and fat rich foods, my blood glucose became very uncontrollable, to the point where it was extremely frustrating. So the promise that they had given me was actually a twofold promise. Number one, eating this way is going to keep your blood glucose low. And number two, eating this way is going to keep your insulin use low. But no matter what I did, no matter how hard I tried, no matter how closely I followed this low carbohydrate prescription, my blood glucose became very uncontrollable. So the blood glucose meter you see on the left right there is a photo of a typical result. In an ideal world, every time I measure my blood glucose, it would be somewhere between 70 and 130. That would be considered in the normal range. And that's the normal range for people who are non-diabetic. So for a person with type 1 diabetes, your goal is to try and keep your blood glucose between those values, and maybe a little bit on the lower end, a little bit on the higher end. So call it maybe like 60 to 150, and do your best to try and stay within that window as much as you can. The problem is that when I would check my blood glucose could be sometimes as low as a 40 and sometimes as high as a 400. And it felt like no matter what I did, no matter how much I exercised, no matter how low carbohydrate my diet was, no matter how much I kept my stress level low, no matter how much alcohol I didn't drink, that my blood glucose was this ping pong, and it was moving all over the place. And it was a 284 today, and then a 312 the next day, and then 162, and then an 82. And it felt like I just had no control. In addition to that, because my glucose was so high, it forced me to have to inject a lot of insulin. So you inject insulin when your glucose is high, and by injecting insulin, it brings your blood glucose down, or it lowers your blood glucose. So I was doing everything I could to try and keep my blood glucose in the normal range. And the two tools that I had at my disposal were exercise and insulin. But I can't exercise every single time I get a high blood glucose reading. So instead, I'd have to rely on insulin, which would mean that on a daily basis, instead of injecting what I consider to be a normal amount of insulin, which is, I'll get into detail about what that is, call it 25 units a day, I ended up somewhere on Sundays injecting twice as much, up to 50 units per day. And this really was frustrating to me, because neither was my blood glucose controllable, nor was my insulin use kept low. And again, those are the two promises that I had been told by my medical team. This translated into a whole collection of problems. My energy levels continued to get lower and lower. I became depressed. I became very anxious. And I love to exercise. It's one of my favorite things in the world. And exercise for me felt very difficult, because my muscles just could not recover from an exercise challenge. And my joints began to hurt. And I just felt like I was living in the body of an 80-year-old man, even though I was only 22 years old. So after about a year of eating a low carbohydrate diet, I said, you know what, enough is enough. I'm not going to live this way, because it just doesn't feel right. And I know that I feel extremely inflamed, and I feel like if this was supposed to work, it should have worked by now. I've given it a full 365 days. I need something different. So I started doing some research, and I wasn't looking to become a vegetarian. I wasn't trying to become a vegan. I just was looking for a way to feel less crappy. And I stumbled upon this idea of eating a plant-based diet. And one guy introduced me to another person who introduced me to another person. Before I knew it, I was under the guidance of a guy named Doug Graham. And Doug Graham went on to write a book called the 80-10-10 Diet, where he teaches people of all shapes and all colors and all sizes how to eat a plant-based diet. And he focuses primarily on eating raw food. He was the first person I'd ever talked to in this world of plant-based nutrition. And he said, hey, listen, I can teach you how to completely change the way that you eat and start to eat foods like you see on the screen here. And by doing so, it's going to lower your blood glucose. It's going to lower your insulin. It's going to get you back to being as active as you want to be. Do you believe me? And I turned to him and I said, no. It's like, why would I believe you? Because I've already been lied to by my medical team. And I would like to believe you, but I'm not sure that I have the ability to do that right now. And he said, don't worry about it. I understand where you're coming from. Are you willing to do an experiment with me? And I said, of course. So he said, great. Come over to my sports retreat and I'm going to show you the system in person, and we're going to spend 7 days together, and I'm going to, completely transform the way that you think. And I said, game on, let's do this. So I flew out to Colorado. I met with him. I hung out for a week. And that was the beginning of a completely new world that I had never even predicted was possible. So what he taught me how to do was to effectively switch fuels. Okay. When I first got to him, my diet was shown on the left-hand side where it says start. Okay. My carbohydrate in green was very low. It was about 100 grams per day, which is technically considered a low carbohydrate diet. And my fat intake was high, and it was about 80 grams per day, as you can see on the right axis. So I was eating, 80 grams of fat per day and about 100 grams of carbohydrate, and then the rest in protein. And in this scenario, again, my blood glucose was hard to control. My insulin use was high. What he had me do was significantly increase my carbohydrate intake to go from about 100 grams a day to, within the first week, north of 500 grams per day. And then by the end of week 3, I was over 650 grams per day. Okay, so that's basically call it a 6-fold increase in my carbohydrate intake. But simultaneously, as I was doing that by eating more carbohydrate-rich foods, I was also substituting those foods for foods that were fat-rich, like red meat, white meat, chicken, fish, olive oil, peanut butter, eggs, bacon, and beyond. And as a result, my fat intake went from about 80, 85 grams per day. Within the first week, I was down to about 30 grams per day. And by the time I hit week 3, I was somewhere between 10 and 20 grams per day. So here I effectively switched fuels, and I became more reliant on carbohydrate energy and less reliant on fat energy. And the question was, what did this do to my blood glucose values? And what did this do to my insulin use? Now, I'm a scientist. The medical world had taught me that every time you eat carbohydrate-rich foods, your insulin use will go up, your blood glucose will go up. That's what they had drilled into my head. And I said, okay, I believe you. Let's see if this works. So when Doug told me, hey, I'm going to try and get you to eat a lot of carbohydrate, the first thing that I thought to myself was, awesome. That means my glucose is going to go even higher, and I'm going to need to use more insulin. So I guess I'll try this experiment, but I'm not really sure what's going to unfold. The exact opposite of what I thought was going to unfold actually unfolded. I predicted that my insulin use would climb from an average of 42 units per day, as you can see here on the left-hand side, to north of 60, maybe 70, maybe 80 units per day. But the exact opposite happened. My insulin use went from about 42 grams per day. And then by the end of week 1, I was down to 32. By the end of week 2, I was down to 26. By the end of week 3, I was down to 23 units per day. So in a 3-week period, I was able to reduce my insulin use by 43%. That's a big deal. That's a very big deal for somebody living with type 1 diabetes. But remember, my insulin use fell by 43% despite the fact that I was eating 6 times as much carbohydrate energy. So what the medical textbooks will tell you is that if you're going to eat 6 times as much carbohydrate, then your insulin use should maybe climb by 6x or 4x or 5x or 3x. It should definitely go north. It should go up. But instead, I was increasing my carbohydrate intake and lowering my insulin use, which no textbook, no blog article, no YouTube video, nothing told me was going to happen. So I thought to myself, wow, this is pretty incredible. The only single human being that knew this was going to happen was Doug. And Doug was the one who was saying, listen, this is the magic of eating a plant-based diet. One thing I did recognize was that my insulin use that had fallen by 43% followed a similar trend as my fat consumption. My fat consumption, again, went from about 80 grams per day down to about 10 to 15 grams per day. And so I said to myself, wait a minute, hold on a second. The two of them, they don't have the same slope, but at least they're both pointed in the same direction. They're both going negative, or they both have a negative slope. That's interesting. I wonder if there's some kind of connection between the amount of fat that I was consuming and the amount of insulin that I'm using. Maybe insulin is dependent on fat intake, or maybe fat intake determines your insulin use. That's an interesting concept. So if you go backwards in time and try and take a look at how much carbohydrate, fat, insulin I was using on a low carbohydrate diet and how that changed, you can see that my carbohydrate intake went from, like I said earlier, 100 to 125 grams per day at the beginning, north of 650. My fat intake went from about 80 down to about 15. And my total insulin use went from 42 units per day down to 24 units of insulin per day. So if you do a calculation to calculate your insulin sensitivity, okay, insulin sensitivity is basically the carbohydrate value on the top of 125 divided by the total amount of insulin, 42. So effectively what you're asking yourself is, how much carbohydrate can you eat per unit of insulin? So if you take 125, you divide it by 42, you end up with a number of 3. That means that at the very beginning of this process, every 3 grams of carbohydrate that went into my mouth required 1 unit of insulin. If you do the same calculation on the right-hand side, 650 divided by 24 is now 27 to 1. So at the beginning of this process, 3 grams of carbohydrate equaled 1 unit of insulin. And now 27 grams of carbohydrate equaled 1 unit of insulin. This is a huge change. This is a massive change. And what that means is that my insulin sensitivity went from a 3 to a 27, which is actually an 800% increase in insulin sensitivity. So this was the first time that I became aware that there was something fundamentally interesting that was happening inside of my body, and I was just looking for more information. I wanted to be able to explain it biologically rather than just telling people a personal anecdote and an N of 1 story that had no scientific basis. So in order to do that, I basically studied for the better part of 2 years just to get into UC Berkeley so that I could go do a PhD in nutritional biochemistry. And then I studied there for 5 years. And while I was there, I read thousands of scientific papers on the concept of insulin resistance. And I was given a specific task to induce insulin resistance in laboratory animals and then reverse the insulin resistance process using either calorie restriction or exercise. And as a result of doing that, I learned an incredible amount of information about the biological processes that create and reverse the insulin resistance process and how that specifically pertained to me and what I had gone through. And then, more importantly, how is this applicable to the wider population? Is this also applicable to people with type 2 diabetes, people with prediabetes? How about gestational diabetes? How about type 1.5 diabetes? And then also, how about people who don't have diabetes? And this is where I really got an opportunity to delve into all of that research and try and understand how this insulin resistance game is played and what you can do about it. So here I am today. I've reduced my insulin use by 40%. Today, on a daily basis, I eat more than 700 grams of carbohydrate per day. I inject approximately 25 units of insulin per day. And that is considered a physiologically normal amount of insulin for somebody of my weight and height. And my A1C values are consistently between 5.4 and 5.7%, which is technically speaking non-diabetic. So every time I go to the doctor and I get, a blood test, they take a look at my blood work and they go, well, that's interesting. According to these values, you don't appear to be living with type 1 diabetes. Clearly, whatever you're doing seems to be working out. So it's a completely different scenario than back in the day when my glucose was uncontrollable, my insulin use was high. Now I'm in a much healthier state of metabolism. I've been there for 21 years, and I hope that it continues to get better over the course of time. So everything that I'm talking about today, including my personal story and beyond, is written about in this book, Mastering Diabetes. So this came out in 2020, just before the pandemic hit, and it became a New York Times bestseller. And I'm proud of that, and I appreciate all of the support that we've gotten along the way. If you have picked up a copy of this book, please let me know in the comments. I would love to get your feedback. And if you haven't picked up a copy of this book and are interested in this concept of insulin resistance, then I recommend going and picking it up, because we've gotten a lot of positive feedback from people. And they say that it's completely transformed the way that they think about blood glucose control or blood sugar control, and that it helps them really understand what is happening under the surface and helps them get rid of a lot of the confusion that they see in the world of the internet. So let's get down into the science here, because the science is really where this is my favorite part of the game. Okay. So You've probably heard this story before. This is the story that I was told when I was first diagnosed. They say all forms of carbohydrate, whether they are whole carbohydrate that come from things like bananas and mangoes and black beans and potatoes, or whether they come from refined carbohydrates like breads and cookies and crackers and chips and waffles and pastries and sodas and white rice and white sugar. Okay, it doesn't really matter. Carbohydrate is a carbohydrate, whether it's whole, whether it's refined. And when you eat those types of foods, they end up metabolizing to this stuff called sugar. And as soon as you say the word sugar, people think table sugar. They think of a white cube. So they go, okay, cool. Potatoes are made of carbohydrate. Carbohydrate causes sugar. Sugar's bad for me because sugar is going to raise my blood sugar. It's also going to make me fat. And then as a result of that, it's going to increase, it's going to cause a quote unquote insulin spike. That's what people online will tell you. And so when there's an insulin spike, either that means that your pancreas is having to work in overdrive in order to manufacture a lot of insulin, or if you're injecting insulin like I am, that means you got to use a lot of insulin in order to bring your blood glucose back down. So the general sort of rhetoric in the world of diabetes is carbohydrates are bad for you. Don't eat them because when you do, they metabolize to sugar. When you metabolize that sugar, it increases your insulin requirements. Okay. Here's the problem. Biological relationships are never linear, absolutely never linear. If you actually take a look at a biochemistry textbook, and if you try and understand how chemical reactions actually are designed and how they interact inside of a intracellular space or an extracellular space, what you will find is that biological mechanisms and biological pathways are horrendously complex, and they have multiple players that function in different parts of the cellular environment, and they have multiple feedback loops to control information flow and to control nutrient uptake, nutrient storage, nutrient oxidation, and movement of information into the nucleus. They're very complex. And as a result of that, this picture, which you see on the screen right here, doesn't really fully describe anything worthwhile because it's just A leads to B, B leads to C, C is bad for you. It's just overly simplistic. The way that biological mechanisms are actually arranged is like the image you see on the left-hand side. And this right here is just a tiny little snapshot of a giant subway map, if you will, of overall human biochemistry. So the deeper you delve into this, the more you realize that trying to explain a potato using just one component of potato, which is carbohydrate, and then trying to come up with a whole collection of arguments about a carbohydrate and that being bad for you is just a biologically inaccurate way of analyzing a very complex food, undergoing a very complex biochemical process, undergoing a very complex collection of biochemical pathways that lead to an actual biological result. Okay. So this model that you see on the screen, overly simplified, completely outdated, but yet it is still the predominant model. It is still the predominant conversation in the world of diabetes, in the world of blood glucose control. And my guess tells me that you've probably seen this argument online. You've probably seen it in some, in a blog article. You probably talked to somebody. You might have seen it in some Instagram post somewhere. If the answer is yes, just go ahead and type it in the chat box. Maybe we can see that. But what I'm curious is, have you seen this type of thing? Because this is what the general world believes to be a true statement. And I'd like to sort of get to a point where we can really understand a little bit more complexity and a little bit more detail, because that's required if you're really going to get to a point where you're going to actually reverse insulin resistance. So I can see Brenda says yes, which is great. So if anybody else feels the same way, then go ahead and put that in there. Okay. So first things first, all carbohydrate on the left-hand side is not created equal. Okay. That's the first thing. So taking a look and saying a banana is equal to a white potato, is equal to a bowl of white rice, is equal to a bowl of pasta, is equal to a Coca-Cola. And all of those foods metabolize to this stuff called table sugar is a fundamentally flawed way of looking at a carbohydrate. Okay. So when this argument basically places this idea that table sugar is bad for you. I know table sugar is bad for you. The ketogenic world knows table sugar is bad for you. You know table sugar is bad for you. Nobody should be talking about table sugar. Like, we should just move on from that, because we realize that's not the right thing to be talking about. But these foods don't metabolize to table sugar. They metabolize to a molecule or collection of molecules named glucose and fructose, which have fundamentally different behaviors than white table sugar that you see on the screen. So these foods don't metabolize to white table sugar. And in addition to that, they don't actually increase your insulin use because you have to be more complex. You're not eating foods in isolation in most situations. And the other foods that you eat along with these foods are going to eventually determine what happens to your pancreas and how much insulin you're secreting. Okay. So in the world of diabetes, there's multiple different flavors. We got the autoimmune varieties on the top left, type 1 and 1.5. These are both autoimmune conditions. Type 1 is what I have, what I explained earlier. Type 1.5 is the adult onset, slow progressing version of type 1 diabetes. On the right-hand side at the top, we got prediabetes and type 2 diabetes. These are what are considered lifestyle versions of diabetes. These are types of diabetes that you can induce onto yourself dependent on your lifestyle, your choices, the food that you put in your mouth, how much food you're consuming, what type of food it is, what type of exercise you're performing, how much stress is in your lifestyle, how much alcohol do you drink, do you smoke cigarettes, and beyond. So these two versions of diabetes are considered lifestyle diabetes. And then the bottom is gestational diabetes and polycystic ovarian syndrome. And these are two forms of blood glucose irregularity that affect women. Gestational diabetes during pregnancy and polycystic ovarian syndrome, which is not a form of diabetes, but it is a blood glucose irregularity that results from a genetic condition that some women are born with called PCOS. So how do you unite all three of these different flavors, if you will, of diabetes? You got the autoimmune on the top left, you got the lifestyle on the top right, and then you have blood glucose irregulators that affect women. Okay, is there something that's common to these three different groups of diabetes? Yes or no? It turns out there is, and the thing that connects them is this thing called insulin resistance. So insulin resistance is a puzzle piece that can grow over the course of time and can shrink over the course of time, and you have full control over it. If insulin resistance grows, then your blood glucose control, whether you have autoimmune versions, whether you have lifestyle versions, or whether you have blood glucose irregularity that affects women, doesn't matter. Insulin resistance grows, blood glucose control becomes harder in all three different groups. Insulin resistance gets smaller and you become more insulin sensitive, then your blood glucose control in all three categories improves. So if you really focus not on the types of diabetes, but on the pathology of insulin resistance, then you can really begin to understand how this one condition can not only affect your blood glucose control in these three different groups of diabetes, but it actually can control your overall risk for chronic disease as a whole. That's why this is such an important message. That's why at the beginning of this presentation, I said, yes, my message is for people with diabetes, but it's also for people who don't have diabetes, because the people who don't have diabetes also can develop insulin resistance, and then it can either turn into diabetes or it can increase your risk for many other conditions. So when I was first given the task in graduate school of trying to investigate insulin resistance and induce it in laboratory animals, my professor turned to me and he said, listen, you're going to become an insulin resistance master. In order to figure that out, you're going to have to go learn how to induce insulin resistance in animals. I know how to do it. I'm not going to tell you the answer. You're going to have to go figure it out. So I said, okay, sounds like a plan. So I went into the research and I started reading paper after paper after paper. I said, how have other people done this before? What can I learn from them and how can I replicate that? So I went into the research and I started reading. And the more information I dig up about insulin resistance, whether it's in mice, whether it's in rats, whether it's in monkeys, or whether it's in humans, the story was the same for all of them. The story that I was guessing would be true in my head was that you can create insulin resistance by feeding organisms sugar. So I was expecting these papers would say that we fed animals or we fed humans a diet that was high in sugar, whether it was table sugar or high fructose corn syrup or some form of liquid sucrose. And that was going to increase their level of diabetes, and their blood glucose and insulin resistance would all go in the same direction. But the more that I delved into the research, the more that I recognized that there was a commonality between all these papers. And the papers didn't talk about sugar. The papers didn't talk about glucose. The papers talked about this stuff called lipid, which is code for fat. Lipid, which is a classification of a type of molecule that is lipid soluble And lipids refer to triglycerides and fatty acids and steroids. So when I started to read this, I was like, oh, this is fascinating. Why are they talking about lipids? Lipids cause insulin resistance? That's weird, right? And then I read more, how free fatty acids inhibit glucose utilization, basically block the use of glucose in human skeletal muscle. That's interesting. They're talking about free fatty acids. Okay. Impairment of glucose tolerance, which is basically impairment of insulin sensitivity in normal adults following a lowered carbohydrate intake. Oh, that's interesting. You're telling me that I lower carbohydrate, increase fat, that I can suppress insulin sensitivity? That's weird, right? The role of fatty acids in the pathogenesis of insulin resistance and non-insulin dependent diabetes. It's like, why are they saying fatty acids again? We're talking about fatty acids causing insulin resistance. The mechanism of free fatty acid induced insulin resistance in humans. Well, wait a minute, this is interesting, right? And this is where it all started to come full circle for me, because I was like, wait a minute, that's what happened in me, I believe, right? I used to be eating a diet that was high in fatty acids. As a result of that, my baseline level of insulin resistance had grown so much that my blood glucose became hard to control. And then when I switched over to eating a low fat diet, I brought my fat level down, and all of a sudden my insulin sensitivity went through the roof. So I'm living proof that story could be true. And now I was seeing it over and over and over again in the research. And as I delved into each one of these papers, they then told the same story. And the story goes like this. Insulin resistance affects two main tissues in your body. Number one, your muscle, and number two, your liver. So whenever I say the words insulin resistance, or whenever you see it online, or whenever your doctor tells you about it, or you read it in a book, okay, insulin resistance equals a dysfunction of two tissues, primarily your muscle and your liver. Okay. Now, insulin resistance, like I was saying earlier, the reason I would like you to care about it, the reason I want you to open your eyes to the idea that insulin resistance is important is because, yes, insulin resistance, like we were talking about earlier, it can affect your blood glucose control for all of the conditions that you see in orange in the top right quadrant. Okay. Type 1, 1.5, prediabetes, type 2, and gestational. All of those are negatively affected as you become more insulin resistant. But in addition to that, there's a whole bunch of other conditions that are negatively affected by insulin resistance. And there's plenty of research to back up all of these claims. So as you become more insulin resistant, your risk for many types of cancer increases. As you become more insulin resistant, your risk for many different cardiovascular abnormalities, including coronary artery disease, which directly affects your heart, hypertension, which is high blood pressure, atherosclerosis, which is the hardening of blood vessels, and high cholesterol, which is increased LDL concentrations. All of those increase your risk for a future cardiac event. Okay, for a future myocardial infarction, which is a heart attack. Okay, so as you become more insulin resistant, you are negatively impacting your cardiovascular metabolism. I know I don't want that, and I know you don't want that. As you increase your level of insulin resistance, you also increase the risk for developing obesity. That's interesting. You also increase your risk for developing fatty liver, because fatty liver disease, or non-alcoholic fatty liver disease, otherwise known as NAFLD, is caused by the excess consumption of fat in your diet, which, as we know, is also associated with the insulin resistance pathology. And we'll go into more detail about that, but they all work together. Lots of fat in your diet increases insulin resistance. That feeds your liver with too much fat, causes too much fat storage inside of your liver. And now you end up with visible nodules inside of your liver. And that can cause a significant liver dysfunction, elevated liver enzymes, and can lead you towards having to get a liver transplant if you don't correct it. So this is very important to understand. In addition, PCOS, we talked about that one earlier. Women who are born with PCOS end up becoming insulin resistant de facto. So it's a two-way relationship here. Now, Alzheimer's disease is actually another very fascinating condition, which is negatively affected by an increasing degree of insulin resistance inside of your liver and muscle. So studies are now showing, and I have two friends that, I'm actually here in Saudi Arabia to give a conference with, that are named Aisha and Dean Sherzai, who are the leaders in Alzheimer's disease research around the world. And they have also demonstrated in their research that there's an incredibly strong connection between the degree of insulin resistance inside of your body and how it can negatively impact cognitive function and lead to cognitive decline later in life. So Alzheimer's disease is actually being classified as type 3 diabetes. And so technically speaking, I could put Alzheimer's disease up in the top right quadrant in orange, because it effectively is diabetes of your brain. And you can think about it that way. And then finally, insulin resistance also negatively impacts the conditions that you see in the top left quadrant. which are conditions that when you are first diagnosed with diabetes, some doctors will tell you that these are inevitable consequences of diabetes and that it's not if, but when you are going to develop them. They tell you flat off, if you don't control this, ma'am, if you don't control this, sir, you will develop one or multiple of neuropathy, which is nerve damage, blindness, kidney failure, retinopathy, and or erectile dysfunction. It's not a fun story. It's not a fun story. I believed that story when I was first diagnosed. And I said to myself, wait a minute, I'm type 1 diabetes. You're telling me that I'm going to develop some combination of these conditions shown here in the top left? Like, I hope to God I don't. That would not be fun. But what I realized is that just because you're diagnosed with diabetes does not mean that you're going to develop any of these conditions. But if you do not correct the underlying condition of insulin resistance, which causes diabetes, if you do not make significant changes to your lifestyle and become insulin sensitive, then these red conditions tend to become much stronger and the chances of you developing them go up significantly. So again, my story here is you have control. You have 100% control. We got to get rid of this thing in the middle and make insulin resistance, insulin sensitivity, and then the degree at which it impacts all of these other conditions goes way down. And as a result, your overall chronic disease risk is significantly reduced. So take a picture of the screen if you have a phone in front of you. Okay. The reason why you develop insulin resistance is because you consume excess saturated fat in your diet. And I'm going to show you the exact mechanism why this happens. So the accumulation of excess saturated fat in your muscle and liver is what traps glucose in your blood. And that causes hyperglycemia, which is high blood glucose, and hyperinsulinemia, which is high insulin output. Okay, so excess saturated fat blocks insulin action in your muscle and your liver, and that traps glucose in your blood, which then causes high blood glucose and high insulin concentrations. So let's walk into it and figure out how this works. Okay, here's step one. Lipids enter your blood before glucose. So what does that mean? Suppose you ate a cheeseburger. You ate the cheeseburger, which is a saturated fat rich meal. Saturated fat lives inside of the red meat, and it also lives inside of the cheese. You got a little bit of vegetables like, I don't know, pickles, maybe a little bit of lettuce, maybe some tomatoes. And then you got also a refined carbohydrate bun on the top and the bottom. So this is saturated fat rich and also refined carbohydrate rich. It's a standard American diet in one meal. It's a horrendous combination of nutrients. And here's what it does to you. You consume this cheeseburger, and the saturated fat molecules, which are shown in yellow, they end up traveling down your esophagus. You chew them up in your mouth. They end up going down your esophagus. They get inside of your stomach. Inside of your stomach is basically just an acid reactor. And it throws a bunch of hydrochloric acid that's manufactured by the walls of your stomach. And it starts to unfold the proteins. It starts to prepare the nutrients inside of that food for digestion. It then passes those nutrients into your small intestine. Inside of your small intestine, you have thousands of microvilli structures, as you can see on the screen here. These microvilli structures are little fingers, and I said thousands. You have trillions of microvilli. And these microvilli are basically little fingers that they kind of look like a little like octopus tentacles. And they line the inside lining of your small intestine. And so what that means is that when nutrients are moving down through the tube of your small intestine, they brush up against these microvilli structures. And when the saturated fat molecules in particular get up against this membrane, they then get absorbed through the microvilli structures and they get put into your lymph system. And then from your lymph system, they get transferred to your blood, and then they get put directly into your blood. So you can see the yellow starts in the cheeseburger. It goes to the microvilli. It ends up inside of your blood, both on the left and the right. Now, as soon as that happens, one of the things that happens is that there's a feedback mechanism directly to your stomach, and it says, hold on. I detect fat. Time to slow down, because for many reasons, fat inside of your digestive system actually slows down the rate at which your stomach empties food into the small intestine. So as a result of that, there's a whole collection of food that is undigested, that is sitting inside of your stomach, that is ready and waiting to go into your small intestine. And it basically causes a traffic jam and says, hold on. Pyloric sphincter, which is just a door that separates the two compartments. It says, hold on. I want you to stay closed. I want you to slow down a little bit. I need a little bit more time to get this fat out of the small intestine and put it in the lymph system. And you should just chill out for a little bit. So as a result of that, there's more food that ends up inside of your stomach for a longer period of time. And that gives you the sensation that you're full. you end up stopping eating. And that's one of the reasons why when you eat foods that are fat rich and tend to be protein rich as well, that you end up getting full relatively quickly, because your pyloric sphincter actually slows down, and that keeps food in your upper digestive system, which gives your brain the sensation that it has to slow down so that you don't get overfull. Okay. So what that means is that lipids get inside of your blood quickly, but yet the carbohydrate energy, which tends to be mainly inside of your stomach at this point, is absorbed very slowly. And that means that your blood glucose level doesn't have a chance to rise because it's undigested and it's just kind of hanging out inside of your stomach for an extended period of time. Okay. So the next thing that happens is that these fatty acids that are now inside of your blood, they are put into these particles known as lipoproteins. So we don't need to geek out on lipoproteins, but just understand that they don't float by themselves. They're put into little packages. And these little packages are floating inside of your blood in the billions or the trillions. And their goal is to basically circulate through your circulatory system to get to their eventual destination. What is their eventual destination? Well, the liver is one and the muscle is the second. So these fatty acids end up getting transported to your liver and to your muscle. And the fatty acids start entering your liver and entering your muscle effectively for free. Now, your liver and muscle, the reason why they take up fatty acids is because they don't really have this very complex mechanism to block fatty acids from getting inside of both tissues. They have sort of relatively weak transport mechanisms that enable fatty acids to get in. It's not really regulated by too much. It doesn't require an escort. It doesn't have a very sophisticated, redundant backup mechanism. And so as a result of that, when there's more fat inside of your blood, there's just more fat that goes into your liver, and there's more fat that goes into your muscle. It's a process known as what's called mass action. And mass action refers to when the concentration here goes up, then the concentration here also goes up, because the amount of mass on this side forces material to move across a membrane to become more concentrated on this side of the membrane. So it's literally, you can just think of a lot of stuff here pushes a lot of stuff here and a lot of stuff there. So the fatty acids begin to accumulate inside of your liver and inside of your muscle. So what? Why is that important? So in this scenario, you also have glucose inside of your blood. And the glucose is in your blood because, again, the glucose came from the bun that you just consumed. And truth be told, glucose is always in your blood. There's always going to have to be a base level concentration. And the amount that came in from the bun is now also trying to find a home. So the glucose inside of your blood goes, hey, can I get inside the liver too? Because I don't want to stay out in the blood. That's not my goal. I'm trying to get inside of the liver. I'm trying to get inside of the muscle. So let me try and make that happen. So the glucose basically tries to get inside of your liver and tries to get inside of your muscle, but can't get inside of your liver and muscle as efficiently as before, because your liver and muscle say, hold on. I got this stuff called fat inside of me. This stuff got here first. As you can see, I'm accumulating this stuff. I didn't really ask for it. It wasn't my choice. I got to deal with this stuff first. So you know what, glucose, I need you to stay outside right now. I need you to just chill out. I'm not ready for you yet. I got to get rid of this fat. I got to oxidize these fat molecules first. And then when they're in a lower concentration, then I can start to pick you up, because I just have too much energy inside of me right now. So the glucose basically says, okay, well, in order for me to get inside of these tissues, I'm going to need an escort. And the escort is actually insulin. So truth be told, insulin is the one that tells the liver and muscle that there's glucose in the blood in the first place. So insulin comes to the liver and muscle, goes, hey, knock, knock. There's some glucose inside your blood. How about you take that stuff up right now? And the liver and muscle, again, they respond by saying, sorry, the fatty acids got here first. Like, not my design, not my control. Yeah, I got to deal with this stuff first. I'm not open for action. So as a result of that, they actually down-regulate insulin receptors. And as a result of that, when insulin comes and knocks on the door, and then knocks on the door again, and then knocks on the door again, effectively what it's trying to do is it's trying to find its insulin receptor, and it's not docking on its insulin receptor because the insulin receptor is not functioning properly. And so as a result of that, insulin is basically just struggling. It's like swimming in this ocean of extracellular fluid, and it's basically trying to get to the muscle cell and trying to get in here, and it can't get there because it can't dock properly. And as a result of that, it's like, man, glucose, I am trying to dock so that you can get inside. And the glucose is like, well, this is problematic because now I got nowhere to go. So the glucose ends up staying inside of your blood. So the glucose effectively gets trapped. So glucose says, all right, look, I'm stuck. The liver rejected me. The muscle rejected me. I can't really go anywhere. So that ends up causing the glucose concentration to rise because there's over the course of time, more carbohydrate is being digested from your small intestine from that bun, and more carbohydrate is being, or more glucose is being put into your blood. But again, that glucose can't really find an exit route. And as a result of that, now glucose begins to accumulate. So in this scenario, your pancreas says, you know what, I think I can solve this problem, because I put out a couple of insulin units. I put out a couple of insulin messengers into the blood to try and go get the liver and muscle to open their doors. That clearly didn't work, because the liver and muscle, they're just not paying attention to insulin right now. So you know what? I'm going to make more insulin. So then your pancreas goes, all right, let me just manufacture more. So instead of manufacturing, call it 3 units of insulin, it then goes and manufactures an extra 2. So now you have a total of 5 units of insulin. So no, the extra 2 units of insulin come to the same muscle, same liver, and they go, knock, knock, knock. It's time to get that glucose out of the blood and inside of both of you. And at a certain point, the amount of insulin that's in your blood can effectively overpower the insulin receptors inside of your liver and muscle. If you just put enough insulin, then more insulin can more effectively translate the signal, more effectively open the doors, more effectively communicate with insulin receptors to basically say, all right, I'm taking over. I have the keys to the kingdom. Your time is to open up and let this glucose in. So your pancreas basically is here as the Superman of the situation that comes to save the day. The problem is that you actually have 1, 2, 3 problems simultaneously that are now accumulating at the same time. Number 1, hyperlipidemia, which is excess fat inside of your blood. This is what caused the problem in the first place. So there was a large intake, a large influx of saturated fat in a short period of time, and that caused a transient increase in the amount of lipid that's inside of your blood. That's problem number 1. Number 2, this causes a transient increase in the amount of glucose that gets trapped in your blood, because the glucose can't get inside of your liver and muscle because the fatty acids beat it there. That's problem number 2. Problem number 3 is that now you have transient increased insulin inside of your blood, otherwise known as hyperinsulinemia, because your pancreas had to come solve the problem by over manufacturing insulin and working in overdrive. So fatty acids caused the problem, glucose got backed up, and then insulin had to come and save the day. Excess fat was called hyperlipidemia, excess glucose, hyperglycemia, excess insulin, hyperinsulinemia. 1, 2, triple whammy. This is insulin resistance. This is the classic game. This is the classic game that unfolds every single time you eat a meal that contains a significant amount of saturated fat. Every single time you cause a traffic jam inside of your liver and muscle, and then that backs up the glucose pathway, which causes insulin to become less effective, which causes insulin to have to be oversecreted. And if you can imagine, if you did this for breakfast, then you did it for lunch, and then you did the next day, and then you did the next day, and then the next week, and the next month, over the course of time, you're forcing your pancreas to have to work a lot harder than it's supposed to. And this is going to cause your pancreas, the beta cells that are manufacturing insulin, to eventually become very tired, very fatigued, and then they're going to commit programmed cell death called apoptosis, and they're going to go bye-bye. And then at that point, you don't have insulin production. Now you're in a pickle. Okay? So that's the first 2 steps. Now, here's what else happens. There's this other thing here called adipose tissue macrophage infiltration. I'm going to explain what this is all about. This happens mainly in people who are obese. It also happens in some lean individuals, but mainly in people who are significantly overweight with a BMI greater than 30. Okay? The research talks about this stuff called macrophage infiltration and or excess adiposity inside of inside of adipose tissue. It's written all over the research, and very few people actually talk about this because it is a highly inflammatory condition, and it can negatively impact the way that your adipose tissue functions. So you take a look at the same picture from before, okay? You got your blood on the right-hand side, you got your pancreas hanging out in the background, you got a lot of saturated fat shown here in yellow in the middle, you got a little bit of glucose and a little bit of insulin. This is the starting point from the previous picture. So these saturated fatty acid molecules, like we said, we used to have your liver and muscle over on the left-hand side, because a lot of those fatty acids ended up inside of your liver and muscle, which is a true statement. But in addition to getting inside of your liver and inside of your muscle, they're also getting channeled directly into your fat tissue. So your fat tissue is actually the right place, the correct place, the safe place. It's the appropriate place to store these fatty acids. And in order to get these fatty acids inside of it, you just have to show up. And the fat tissue knows exactly what to do in order to recognize it, in order to pull it in, and in order to store it for long periods of time. So saturated fatty acid goes and knocks on the door and goes, hey, by the way, there's a lot of me in the blood. What do you want to do about it? And the fat tissue goes, all right, cool, sweet. Well, I'm your home, but come inside. So the fat tissue actually starts to expand just a little bit with every single meal that you consume. And these cells, these adipose tissue cells called adipocytes, end up getting just a little bit bigger today, and then a little bit bigger tomorrow, and a little bit bigger, and a little bit bigger, and a little bit bigger over the course of time, especially when the consumption of fatty acid is puts you in a positive energy balance, meaning that you're consuming more total energy than you're expending. In other words, when you consume a high calorie diet and you're not active, that means you're accumulating energy and you're not getting rid of it. And as a result of that, you have a net excess of energy. So the excess begins to build up inside of these adipose tissue cells, and it causes them to swell. And this is called hyperplasia, when the cells become very large. And at a certain point, these cells actually swell up like a balloon, and some of them can break open. And as soon as some of these cells start to break open and store large amounts of fatty acids, it causes a huge problem, because the cells, once they break open, they spill their internal contents, their intracellular material, into the extracellular space. And as soon as that material is put in the extracellular space, then all of a sudden the tissue goes into this cytokine panic mode. All of a sudden it's like emergency, emergency, emergency. This stuff is not supposed to be outside of the cell. It's supposed to be contained inside of a cell. Why is it here? Get rid of this stuff immediately. So it starts to send out these things called cytokines. You probably have heard about cytokines when COVID-19 was around. Everybody was talking about cytokine storms because it can become this feed forward mechanism that can end up in a very, very dangerous metabolic state. So your adipose tissue sends out cytokines, and these cytokines are called TNF alpha and MIP1 alpha. These, you don't have to remember these, but these are basically just names of these molecules that are sent out by the adipose tissue, the purpose of which is to go attract these little things, these little biological Pac-Men that are floating in your blood. These biological Pac-Men are called macrophages. And macrophages are there to eat the unwanted cellular material that's not supposed to be there. Okay, these are literally biological Pac-Men, and they come to the site, and just like you get in the video game, they're sort of coming and they're like gobble, 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 gobble. What can I eat? What can I eat? What can I eat? And they find that all of this excess material, and they just start to endocytose it and suck it up and just clear the area so that they can return the adipose tissue to a much more anti-inflammatory mode. So in order to do that, this is called macrophage infiltration, because the macrophages are literally recruited to the site of inflammation, and then they penetrate the tissue to get to this material to start gobbling it up. And the problem that this creates is that as soon as the tissue goes into this distress state, now it starts to block the amount of fatty acids that come inside of it, because the more fatty acids the tissue accepts, the more of this problem is going to happen. So the tissue goes in this mode where it's like, hold on. Stop, like, give me the macrophages, get them over here, start gobbling up this material, and stop importing fat. I do not want fat right now. And so it blocks, that creates a traffic jam again, and it blocks free fatty acid uptake. And that means that fatty acids begin to pool inside of your blood where they don't want to be. And then as a result of that, they end up trying to release a lot of fatty acids that are stored in order to relieve some of the pressure that's built up inside of this tissue. So they literally start leaking fatty acids into the blood. And as a result of that, now the blood is accumulating fatty acids once again. So in effect, this tissue is basically saying, hold on, I'm literally breaking. So get the macrophages over here to fix this stuff. And then I'm just going to start to offload some of this material so that I don't break more. And in this process, that causes your fatty acid concentration inside your blood to go up, which is not awesome, because this is, again, hyperlipidemia, which means excess fat inside of your blood transiently. And then when that happens, now, well, where's the lipids going to go? The lipid says, well, I can't get inside the adipose tissue because it just kicked me out. Now I got to go somewhere else. And so it ends up moving towards your muscle and towards your liver and towards your pancreas. And then it starts the same cycle that you saw on the previous slides. More fatty acids, boom, right into the muscle, right into the liver, exacerbates insulin resistance in those two tissues. Now those two tissues are even more, they're more forced to take up free fatty acids, even though they don't necessarily want it. And as a result of that, it accelerates and it increases the magnitude of insulin resistance inside of both tissues. Okay. Now, here's the final thing which can happen. There's the beta cells. These are very specific cells inside of your pancreas, which are responsible for secreting insulin. They're the only cell type in your entire body that can manufacture insulin. Okay. So when something happens to your beta cell population, if that population gets compromised in any way, shape, or form, you run into a system-wide defect. Okay. This is called diabetes. This is called diabetes that causes your blood glucose to go very high. And it can cause a significant number of metabolic consequences down the road. So in other words, your beta cells are extremely important in overall glucose metabolism, in overall metabolic health. And so it's to your advantage to be very protective of the beta cell population inside of your liver. I'm sorry, inside of your pancreas. Now, beta cells make up about maybe 1% of your total pancreas. Okay, very small percentage. And what can happen is that there's a problem called lipotoxicity. Lipotoxicity refers to an excess lipid presentation or an excess lipid load inside of beta cells that happens mainly in obese people. And when that happens, that can actually cripple the ability of beta cells to manufacture and secrete insulin, and it can cause them to commit suicide. Okay, so here's how that happens. Okay, inside of your beta cells, there is a very, very sophisticated and highly active network of what are called mitochondria. Mitochondria are present in every cell in your body. And these mitochondria have a wide array of functions. Okay, their main function is to import that. You can think of them as like energy factories. They import fuel. They run the fuel through this thing called the electron transport chain. And then that increases ATP generation. So they basically suck fuel in and then they kick out energy. Okay. So it's like, I don't know, you can think of it as like a solar panel, right? It sucks in sunlight, right? It's exposed to UV radiation and then it kicks out electricity. It's the same thing. You give it fuel and then you end up creating energy, right? So these are small little energy factories and they happen to be very, very, very abundant inside of beta cells because they have a very specific function. And their function is to basically help in the production of insulin. It's a very complex system and we don't need to go into too much detail about that. But what I do want you to focus on is that when there's a lot of fatty acids that are being presented to the beta cells because there's a high concentration of fat inside of your blood, then these fatty acids can annoy these mitochondria. And so these mitochondria produce ATP. They take the fatty acids and they go, okay, great, now I'm going to go make some ATP. So they do. But in the process of making ATP, they also make this stuff called free radicals, which are called reactive oxygen species. And free radicals are really dangerous molecules. Okay, you can think of this as like unwanted byproduct. It's a waste material, and the production of free radicals increases as the flux or the amount of fatty acids that goes through the mitochondrial network increases. So when this happens, these mitochondria generate a significant amount of these free radicals, reactive oxygen species, and these guys are basically highly unstable molecules. And what they do is they can go and they can attach to DNA, okay, and they can actually cause direct DNA damage, whether that's in the nucleus or whether it's in the mitochondria. Neither one of them is a good scenario because anytime you alter DNA, you are going straight to the central computer, and you are jeopardizing the health of the cell as a whole. Okay, so it interacts with DNA, and it can cause DNA single strand breaks, and it causes DNA double strand breaks. Both of them are extremely dangerous. Number two, these reactive oxygen species can also go affect and attach to proteins. And when they do, they cause protein oxidation, which is otherwise called oxidative stress. And this can help age a cell faster than it's supposed to age. And this can help the cell get to a point where it says, you know what, this is too dangerous. I'm going to commit suicide. So it accelerates the protein oxidation process. And then in addition to that, it also can cause damage to lipids. And this process is called lipid peroxidation. So we have DNA damage, we have protein oxidation, and we have lipid peroxidation. The combination of the three of those makes it so that a normal islet that you see on the left-hand side, which is normal size, manufacturing a normal amount of insulin, all of a sudden becomes hyperplastic because now it's starting to secrete excess insulin because it had to, because it was forced to, because there's too much insulin resistance inside of your liver and muscle. So now it's a larger cell that's ramping up its production, and it's basically working in overdrive to make more insulin, more insulin, more insulin, more insulin. And in the same time, it's exposed to saturated fatty acids. And as a result of that, at a certain point, the cell just becomes tired. The mitochondrial network says, I'm producing way too many reactive oxygen species. This is not going to work. The cell itself is like, I'm producing way too much insulin. I cannot do this in an infinite time period. I can't do this anymore. And then the beta cell commits what's called programmed cell death, otherwise known as apoptosis. And so when that occurs, the cell basically goes into a self-defense mode, and it basically stops insulin production. And then it triggers a whole collection of biological processes that says, kill me now. I'm going to try and protect the rest of this beta cell population, and I'm not going to basically like compromise their function, get rid of me, my time is over. And then boom, the cell literally commits suicide. Macrophages come in, clear it out, and it's done. And it will not replace itself. So this is a one-way path towards a reduced beta cell population. So this is what the lipotoxicity pathway can create. Again, it happens mainly in people who are living with obesity, but this is another example of how lipids can negatively impact your liver and your muscle and your adipose tissue and the beta cells inside of your pancreas, all four of which have to work together in order to allow this glucose metabolism to work properly, and all four of which are negatively impacted by the presence of that one molecule of the saturated fat. Okay. Now, I told you earlier that I have autoimmune diabetes. And what that means is that I have an autoimmune version of diabetes, which means that I cannot secrete insulin. And as a result of that, I have to inject insulin from the outside world. Now, insulin resistance is canonically thought of as basically being a condition that only affects people who are overweight and people who are sedentary. And that leads to both prediabetes and type 2 diabetes. But what people who are living with type 1 diabetes don't recognize, and doctors who treat people with type 1 diabetes don't recognize, that you can actually be living with both type 1 and the symptomology of type 2 diabetes simultaneously. And this is fascinating because this is what happened to me at the beginning of this process. I have autoimmune diabetes, which means that there's immune cells which are basically going and crippling and killing the beta cell population. You don't have a choice. They come in, they clear out the beta cell population, and they're done. And so as a result of that, I can't manufacture insulin. So autoimmune diabetes basically just kills these cells before you even know it. And as a result of that, now you have a compromised beta cell population. If you add into that insulin resistance, which is the saturated fat accumulation that causes lipid accumulation inside of your liver and your muscle and your adipose tissue, this can then cause, so this means that you are now living with double diabetes, which again is the presence of type 1 diabetes, autoimmune diabetes, and the symptomology of type 2 diabetes, which means that your liver is negatively impacted, your muscles negatively impacted, and your adipose tissue is negatively impacted. So those three tissues, which normally become impacted by a saturated fat intake, are still getting impacted by a saturated fat intake, but your pancreas is already getting crippled by the autoimmune attack. And now you got two huge problems, and both of them compound upon one another. So effectively, what can happen in this scenario is that if you're already living with autoimmune diabetes and you choose to eat a low carbohydrate, high fat diet, which tends to be very high in saturated fat by design, then what you are likely to see, okay, so this is sort of where people get confused. And this is where I will fully admit that the story that I'm telling you right now can become confusing, because if you go and look online and you go talk to people who are eating a low carbohydrate diet, they're going to be like, everything that you just heard from that guy named Cyrus online, like, what is he talking about? Like, I didn't experience any of that. Like, that's not true, right? I don't care what the research says. I switched over to eating a low carbohydrate diet, and guess what happened? My blood glucose came down. My A1C came down. Guess what? I lost a ton of weight. Yeah, I lost, 25 pounds. I lost 30 pounds. I feel better than ever before. My cholesterol came down. My triglycerides came down. My blood pressure came down. What is the problem? I don't understand. All I do is I eat more meat and more dairy products, and I've eliminated carbohydrate, and now I feel like $1 million. Okay. This is exactly what happens to people who eat a low carbohydrate, high fat diet. Okay. But all of those changes unfold in the short term. Short term means 6 months, 12 months, 3 months, somewhere within usually the first year of transitioning to a low carbohydrate diet. All of those things are true. These people are not lying. Okay, maybe you guys have gone through that yourself, or maybe you know somebody who has. What they don't know is that if they literally hit the fast forward button and they go blah, 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 and they go to 5 years in the future, and then they take a look at themselves, then the picture that they're going to see of themselves 5 years from now does not look like the picture of themselves 6 months into the process, because that picture of them 5 years down the road is a lot worse off than they are right now. So you get all these short-term improvements that then become long-term medical liabilities, because the insulin resistance process takes time to unfold. And as your liver begins to accumulate more and more and more and more and more lipid, and as your muscle begins to accumulate more and more and more and more lipid, and as your adipose tissue begins to accumulate more and more and more lipid, then it causes insulin resistance in 3 very large tissues. Then it can also It can also increase your LDL concentration, which is not good because that definitely can increase your risk for a future cardiac event. And it can increase your blood pressure simultaneously. It can trigger the atherosclerotic process, which can then harden blood vessels, causing oxidized LDL inside of the actual wall of blood vessels. So what I think the diabetes world suffers from is a fundamental misunderstanding of one variable, which is time. And that even though eating a low carbohydrate diet might give you all of the short-term improvements on the left that you see in the short term, if you add time to that metabolic state and you move forward into the future and you continue eating that same type of diet, then you're likely to develop these longer-term side effects. And these longer-term side effects are things that the research is ripe with. And you see in large-scale studies that follow people over the course of 6 years, 8 years, 10 years, 15 years. If you take these very large data sets and look at free-living humans who are consuming more fat and more protein and less carbohydrate energy from plant material, you will see that there's a significantly increased risk for mortality from cancer, for mortality from cardiovascular disease, and for mortality from diabetes. Okay, so all of these things are there. There's not stories I'm making up. These are all things that are grounded inside of the research. And unfortunately, most people prioritize the short term and sacrifice the long term and don't realize that they're actually turning themselves into a larger, they're increasing their overall chronic disease risk, but they're unaware of it at the time. So the question really becomes, well, what can you do to solve this problem? If the picture that I presented to you is that, saturated fat in combination with refined carbohydrate is really what's causing this problem, but mainly driven by saturated fat metabolism that affects your liver and your muscle and your adipose tissue and your pancreas in a negative manner. Well, then what do you do? How can you solve this problem? Well, okay. So in order to answer that, all you got to do is take a look at the foods on the screen. Okay. The foods on the screen are specifically designed. There's a lot of things in common. Number one, you see only plant material. Okay. Everything that you see on the screen is a plant or grows on a plant or came from a plant or is the fruit of a plant or grew in the ground as part of a plant. Every single thing on the screen. Okay. And the foods that you see are also very colorful. They're very antioxidant rich because antioxidants are pigments and they're there to protect the DNA of that actual fruit or vegetable against UV radiation. But those antioxidants are actually really good for you because they help bathe tissues in anti-inflammatory compounds that can help stimulate normal metabolic processes. In addition to that, these foods they're very colorful, they're very tasty, a lot of them are very filling, and they're also extremely high in fiber, and fiber is your friend when it comes to this dietary game. Okay. In addition to that, all the foods that you see on the screen here are low in saturated fat by design. Okay. I told you earlier, the saturated fat is a very problematic component of food. And when you consume a significant amount of saturated fat, you set yourself up for increased chronic disease risk. So if you can envision a world where you transition your diet to eating mainly the foods that you see on the screen here, even if it's not 100%, that's fine. Then you can get to a point where your saturated fat intake used to be high and now it's low. And as a result of being low, you're now undoing the traffic jam that you built up inside of your liver and muscle and adipose tissue and pancreas. Okay. So the foods that we created a traffic light system, green light, yellow light, red light, just to make things as simple as possible. Okay. So the foods in the green light category include fruits, starchy vegetables, which are vegetables that grow on the ground, like potatoes and yams and squashes. Okay. I'm also going to put corn in that category because it acts like a starchy vegetable, even though it's a grain. Okay. And then we have non-starchy vegetables like tomatoes and cucumbers and cauliflower and broccoli and okra and, vegetables that generally don't have a starchy consistency. Then you have all legumes, beans, lentils, and peas. You got green leafy vegetables, intact whole grains, which are whole grains that are minimally processed, as well as herbs and spices. So the foods in the green light category are those foods right there. The foods in the green light category you can eat in, I'm going to say, unlimited quantities, unlimited with an asterisk, meaning I'm not suggesting that you go overeat these foods. I'm suggesting that you eat these foods to satiation and then stop. and don't have to worry about calorie counting and don't have to worry about portion control and don't have to worry about how much of them you're eating, because the presence of the fiber and the water, what's known as bulk, is actually the single most important component that can talk to your digestive system, that can send a neurological signal to your brain that says, "Oh, slow down, slow down, slow down." Now, what that means is that the foods that are on the left-hand side right here, they contain a significant fiber content and a significant water content. And truth be told, they contain 9 classes of macro and micronutrients. Okay, and those classes include carbohydrate, fat, protein. Okay, those are the macronutrients. That's where you get your energy. Carbohydrate, fat, protein, 1, 2, 3. In addition to that, there's vitamins, minerals, fiber, water, antioxidants, and phytochemicals. I'll say that again: carbohydrate, fat, protein, macronutrients. The micronutrients are vitamins, minerals, fiber, water, antioxidants, and phytochemicals. Okay, these 9 classes of components, or these nine classes of nutrients, are all packaged into one complex 3-dimensional structure. And that 3-dimensional structure either takes a shape as a peach or a chickpea or brown rice. Okay, all of those components are inside of every single one of those foods. They just happen to be in slightly different proportions. Fruits might have a slightly higher carbohydrate content than a green pepper, and beans, lentils, and peas might have a slightly higher protein content than a banana. Okay, so think of that all 9 of these components as being present inside of all whole foods. It's just that there's sort of like a slightly different amount of carbohydrate, a little bit of difference in fat, and a little bit of difference in vitamin, mineral content and whatnot, but they're all there. So if you eat a wide selection of them, then mathematically what that suggests is that you're going to be taking on an appropriate amount and an adequate amount of all 9 classes. And the beauty is that because they contain fiber and water, which are 2 of the micronutrients, the fiber and water combine into this one thing called bulk. And bulk, when you consume it, goes in literally inside of your small intestine. It starts to stretch the walls of your small intestine. And there's stretch receptors inside of your small intestine that send this neurological signal up to your brain that say, "Hey, there's something inside of me, slow down." And your brain receives the signal. It's like, hold on. There's stuff inside of my digestive system. Reduce appetite. So it flips a switch. And then the neurons inside of your brain that then communicate with your digestive system basically say, "Okay, time to slow down." And your digestive system says, "Okay, ask for less food. And as a result of that, you get less hungry. And you get to a point where you're like, "You know what? I think I'm full. I don't want to eat anymore." Okay. It's a 2-way phone call that initiated in your digestive system, goes up to your brain, goes back down to your digestive system, and the 2 of them are talking to each other at all times. And when you eat foods that contain fiber and water, like you see on the screen here, that 2-way phone call is basically responsible for turning your hunger signal off when there's stuff inside of your small intestine that stretches the walls. And as a result of that, you get full relatively quickly. But the beauty is that you haven't actually taken on that many calories, because these foods tend to be low in their calorie density. And that's a good thing. So you can eat a significant amount of fruits, and you can eat a significant amount of beans and vegetables and intact whole grains. And you're actually not taking on nearly the amount of calories that you would be taking if you were eating red meat or white meat or dairy products. And as a result of that, you get full, but your calorie count is nice and low. And that's what enables you to either not gain weight or lose weight, which is necessary for the wide majority of the population. Now, in addition to that, there's also yellow light foods. And these yellow light foods are nuts, seeds, avocados, coconuts, and olives, which tend to be, they're plant-rich foods, or they're plant foods that tend to be rich in fatty acids. And so as a result of that, we say you can go ahead and eat them. Just be aware of how much you're eating and try and keep your, a little bit goes a long way. And then we also put pastas and breads in this category because pastas and breads tend to be processed. And as a result of that, they can cause blood glucose irregularities. And then the foods in the red light category are foods that contain mainly saturated fat. And those are dairy products, eggs, red and white meat, fish and shellfish, and then oils of any kind, saturated fat, and many oils are saturated fat rich. And then in addition to that, we got refined sugars and pastries and breads, which tend to be highly refined substances that can then cause abnormal glucose metabolism inside of your liver. All right. So if you can just go ahead and take a photo of the screen, do whatever you want. This right here is your key to reversing insulin resistance. Take a look at the screen and ask yourself, where are my foods? The foods that I put into my body, are they generally on the red side? Are they generally on the green side? Are they generally in the yellow? or are they spread out across the room? Most people, when I ask that question, they say, well, it's kind of spread out. I got some over here and a little bit over here, and it's maybe like 33% in each category. And I say to them, okay, great. Imagine a world in which you move from, a third in each category to 80% in the green light category and just a little bit in the yellow and a little bit in the red. Okay. If you want to go at 100% in the green light category and ditch the yellow and the red, by all means, you can do that, but you don't have to. Let's get to 75, 80% in the green category, and then a little bit in yellow and a little bit in red. If you can visualize that, and if you say to yourself, okay, cool, I want to move in that direction, then I'll give you a guarantee that you're going to make significant improvements to your overall metabolic health because of everything that we've talked about leading up to this point. This is what I'm talking about. I'm not talking about eating salads with a bunch of lettuce and a couple of tomatoes like you would get at a restaurant. Okay. I'm talking about satisfying foods, soups, potatoes loaded with lentils, bean salads, fruit bowls, acai bowls, tofu scrambles. Okay. Rich, filling, intensely sweet, very delicious, fruit-rich meals, banana and ice cream. If this stuff looks appetizing to you and you're excited about it, then cool, join the club. So am I, right? These are the types of foods that are extremely high in micronutrient content. Again, the micronutrients are the vitamins, minerals, fiber, water, antioxidants, and phytochemicals. Those are the 6 classes of nutrients that you want to maximize with every single bite of food. When you eat a lot of vitamins, a lot of minerals, a lot of fiber, a lot of water, a lot of antioxidants, and a lot of phytochemicals, those are the micronutrients. Those are the information that gets sent into your mouth, into your digestive system, that goes and penetrates into tissues and starts to clean up a lot of the mess that's been caused by the standard American diet or low carbohydrate diet and get it out of there and start to really restore tissue function inside of your cardiovascular system, your liver, your kidney, your muscle tissue, your brain. And it starts to make you feel like a much more human. It starts to make you feel more human, and it starts to reverse many disease processes simultaneously. Okay, so the final thing I'll say here is that we recommend taking a step-by-step approach. Okay, so you look at the foods on the screen and you go, okay, cool. I think I can do this. I think I want to do this. I think I can move over to the green light category, but do I have to do it right away? Do I have to just like give up everything in the red light like tomorrow? Like, what's the timeline? How do I do this, right? And my answer to you is there is no timeline. I don't want you to stress yourself out. I do not want you to cause anxiety to yourself. I do not want you to feel like you're racing against the clock. Okay, this is not a competition. Okay, this is not a sprint. This is a marathon. The way that we do it, the way that we have changed the lives of more than 10,000 people using this approach is very, very detailed and extremely sophisticated in how step-by-step it is. I only want you to make small changes and compound those over the course of time. So what that means is that on the first week or 2 weeks, I want you to change just your breakfast. That's it. I don't want you to touch your lunch. I don't want you to touch your dinner. Just literally change your breakfast and start to migrate over to eating 100% plant-based meal. You can have oatmeal with fruits on top of it. You can have a fruit bowl by itself. Heck, you can eat some potatoes and salsa if you want. It doesn't really matter. You can eat some black beans and tofu if you want, depending on whether you want sweet or savory. But I want you to just focus on eating your breakfast as a plant-based meal and figure out all the logistics surrounding it. How much, what type of carbohydrate material do you want to put into your mouth? Carbohydrate-rich material do you want to put in your mouth? Is it sweet? Is it savory? How big does a meal have to be? Is it liquid? Is it a smoothie? Do I have to cook it? Do I have to take it to work? Do I have to put it in a Tupperware container? You figure out all the logistics. But once you get to the point where you feel comfortable about that, then you move to your lunch. So you move to your lunch, and your lunch basically takes another week, another 2 weeks. Take your time. Figure out all the logistics. What do you like to eat? How much? How are you going to get it to work? Are you going to bring it home? Does it have to go in the microwave? Does it not have to go in the microwave? Can you make it on the spot? You got to prepare it beforehand. You figure it out. Then you get to dinner. You do the same thing. Am I eating with my family? Am I eating outside? Am I eating on the road? How many people am I serving for? When do I have to make it? How long does it take me? What looks good? You figure that out. Okay. There's tons of recipes that we can provide for you, but the goal is you take a look at those recipes and you just make them and you figure out all the logistics for your lifestyle. Then you get to dessert. You do the same thing. What do I like to eat? How sweet is it? What is it made out of? Is it frozen fruit? Is it something else? Do I get it at the store? Do I make it myself? How do I eat foods that are whole food plant-based that don't have any added sugar or added high fructose corn syrup that tastes really good that give me that, after dinner sweet feeling. Great. So then you get to a point where you've changed your breakfast, your lunch, and dinner, and that can take, and your dessert, and that can take a month. It can take 2 months. It can take 3 months. I don't care. It doesn't matter to me. Okay. I just want you to get to a point where you feel comfortable with all meals and you've changed them sequentially so that you feel like you're making some significant changes. Then you can begin an intermittent fasting regimen. We didn't even talk about intermittent fasting at this point yet. We can go on and talk about that at some other point, but intermittent fasting is a way to restrict your food intake, or basically to skip one meal of the day if you want, literally just one meal. And that can have a profound impact on how your cardiovascular system and liver and pancreas and muscle tissue behave. And this can significantly improve glucose metabolism in 1,000 different ways. So you get to a point where you're intermittent fasting, either on a daily basis or maybe once or twice per week. Then you start to add movement into your regimen. And daily movement, usually around 30 to 45 minutes per day. You can start small, you can ramp it up over the course of time, and you start to get that in your lifestyle. So now you change your diet on the left, you started intermittent fasting, and then you have daily movement. 1, 2, 3, triple whammy. Insulin sensitizing, insulin sensitizing, insulin sensitizing. Insulin resistance literally cannot live inside of you if you are doing all three of those. It cannot live inside of you. If you're doing them and you're doing them consistently, it's gone. And it'll take time to reverse, but it's gone and it will not come back. Okay. And then in addition to that, if you're injecting basal or bolus insulin, or if you're taking medications like a statin medication or blood pressure medication, talk with your doctor, adjust your dosing on a frequent basis, and eventually get to a point where maybe you need less, or maybe you don't need any at all. Okay. So the step-by-step approach is important. And I want you guys to not feel the pressure to have to go from the red light category to the green light category too quickly, because that can cause emotional distress, and it can, quite honestly, just make it a pain in the butt. So when you do this, your saturated fat intake goes from high to low. Your carbohydrate intake goes from low to high over the course of time. Your insulin use, whether you inject it from the outside world or whether it's manufactured by your pancreas, starts high, goes low, and that's a really good thing for you. Okay. When you can bring your insulin use way down and your carbohydrate intake up, that right there is the definition of insulin sensitivity. Okay. And then finally, your blood glucose is probably it's going to come down over the course of time, but it might do some funny things in the meantime. It'll come down, that'll go back up, and then it'll wiggle all over the place, and it'll be a little noisy. That's okay. Doesn't matter. All we're looking for is a downward trend over the course of time. So eventually you'll get to this final point where you have low saturated fat, low blood glucose, low insulin, and high carbohydrate intake. This right here, this is where you want to be. This right here is synonymous with exceptional metabolic health. And if you can get to this point, even if it takes you 6 months or a year or 2 years, I don't care. It doesn't matter to me. What I care about is that you develop habits that stick and that you make this a sustainable lifestyle over the course of time. Okay. I can show you, testimonial after testimonial after testimonial from a bunch of people, living with type 1 and type 2 diabetes, who have reduced their A1C values, who have cut their fasting blood glucose, who have lost tremendous amounts of weight. In this case, Chris Hertel is living with type 1 diabetes for more than 57 years. He lost 76 pounds. He reduced his insulin use by more than 50%. He eliminated 12 oral medications, reversed obesity, reversed hypertension, reversed high cholesterol, and reversed rheumatoid arthritis. 4 conditions. Rheumatoid arthritis was an autoimmune condition that his doctor said was irreversible, and Chris proved him wrong. Joaquin's another perfect example. Lost 35 pounds in the first 60 days of doing this. Fasting blood glucose fell by 50 points. Carbohydrate intake went up significantly. Energy levels significantly improved. Completely new man. He's changed the lives of 20 people at this point. Okay. John Dill, another perfect example. He's lost 70 pounds. He made significant changes. He went from being pre-diabetic to non-diabetic, and he has more energy than he knows what to do with. He won't give up. He's too strong-willed, and he absolutely loves his lifestyle. And he's now got his, other family members on the plan. Makes a big difference. Bob, another perfect example, type 2 diabetes, lost 100 pounds in 8 months. Fasting glucose came down by, 2/3. Lost 4% on his A1C, cholesterol down, LDL down, blood pressure down. And you can see he's a transformed man from the inside out. So, this is not an end of one story. We've changed thousands of people's lives. And I know you guys have the opportunity to change your life as well. Okay, we just have, literally I could do another hour and a half presentation with nothing but, success stories, but I won't bore you with that. Your basic guidelines here are this: eat a maximum. You can take a photo of the screen if you want. Okay. Eat a minimum of 70 to 80% carbohydrate from whole plant foods. And then the rest should come from fat and protein, about 10 to 15% from one of those. sweat for 30 to 60 minutes per day, intermittent fast when necessary, and then join a community of other people so that you feel like a normal human being, like you're not some weirdo that's doing this in a vacuum. And you can have a good time, share recipes with one another, give each other a high five, hug each other, have a good time, and make life better for all of you. Thank you for the time. Thank you for listening. And any questions you guys have, I'm open.
Great. Thank you so much, Cyrus. That was a very, very comprehensive explanation of diabetes and how they all relate with each other. So we're going to now begin our Q&A session. And I just want for the audience, I just want to go over a couple of quick things. We don't take, where can people get your book, and how can they follow you on social media?
Where can they get the book? Great question. Okay. So just go to Amazon. That's probably the best place to buy it. Just go to Amazon, literally type in the words "mastering diabetes" and it'll pop up. You can buy the book in either hardback, you can get in paperback, you can get it in audiobook. We spoke the audiobook, myself and my business partner, Robbie. And then you can also get it in Kindle format as well. And then if you want to follow on social media, literally go to any social media platform. It could be TikTok, it could be Instagram, it could be YouTube, it could be Facebook. Just type in the words "mastering diabetes" and you'll find us. We're pretty much everywhere.
Great. Thank you. All right. Sure. For the Q&A for the audience, just a couple of ground rules. We don't take questions directly from chat. You need to raise your hand in Zoom if you're not familiar with that. What you need to do is go to the reactions button second from the right and click on that, and then you'll select the raise hand function in the menu that pops up. When I call on you, I'll ask you to state your where you're from and ask your question. And we just ask the questions are brief and on topic. And I just have a couple of questions for you to get started. So you mentioned that type 1 diabetes is caused from an autoimmune, or at least yours was caused from an autoimmune response. What caused that autoimmune response? Is that documented?
Great question. The world of autoimmunity, autoimmune experts don't know the full answer to that question. They have discovered that there are multiple different factors that can increase your risk for the development of autoimmune conditions, especially type 1 diabetes, but none of them are like conclusive stories. One of them is a lot of individuals get diagnosed with type 1 diabetes after contracting a virus. In particular, there's one virus called the Coxsackie virus, and people who develop the Coxsackie virus usually won't have any symptomology. It's not like you're starting to cough or, you don't have any respiratory symptoms, but then as soon as that's over, boom, all of a sudden you can get type 1 diabetes. Other individuals actually can increase their risk by, this is interesting, consuming cow's milk protein before the age of 1. Okay, so if you were bottle fed from formula that contained cow's milk protein in it, otherwise known as casein, there's studies that demonstrate that people who consume casein end up at before approximately the year of 1, then they can end up with significantly increased risk over the course of time, like as they become an adolescent. And when in my particular situation, I went backwards in time and I said, "Hey, Mom, how long was I breastfed for?" And she goes, "Oh, I could only breastfeed you for about 2 months. Because it was really challenging for me at that point." And then I was like, "Oh, okay, well, that's really interesting information," right? I don't blame my mom in any way, shape, or form, but I think that may have contributed. I also tended to drink a ton of milk when I was a young kid. The third thing is there's another mycobacterium called MAP, which is called Mycobacterium avium paratuberculosis. Don't memorize that. But effectively, it is a mycobacterium that is found inside of the digestive tract of domesticated cows. So some domesticated cows end up, when they're in pasture, when they're being raised in like a large livestock setting, they end up developing this thing called Johne's disease. And Johne's disease basically is a muscle wasting condition. And it's caused by this MAP bacteria that's inside of their digestive tract. So what ends up happening is they end up pooping, and the fecal matter has the live MAP bacteria, and that gets onto their hooves and it gets onto the ground, and then it gets transferred to other cows and it can spread that way. So when these animals end up going for slaughter, they end up with the MAP bacteria externally, and then it gets on the gloves and it gets on the sort of like coat, the gloves and the hats and the clothes of the slaughterhouse workers. And then the MAP bacteria, what's suspected is that the MAP bacteria can end up getting packaged into meat that comes out of a slaughterhouse, literally live MAP bacteria. So it gets into dairy products and into meat. And that way, when it goes to the grocery store, it's still alive, which means that when you bring it home, there's live MAP bacteria, which when you ingest it, actually can trigger a whole collection of biological processes that increases your risk for two autoimmune conditions. One of them is type 1 diabetes, and the other one is Crohn's disease. And so there's some fascinating research that actually demonstrates that you can buy milk off of the shelf and you can test it for live MAP bacteria, and it tests positive in something like 3 to 5% of all milk. So it's not a very large percentage, but it is present. But people who are living with type 1 diabetes, a very large percentage of them, more than 90% of them, test positive for MAP bacteria inside of them, right? Which is again, it's not conclusive, but it leads you to down the path that's MAP is causational in autoimmune diabetes, and it happens to be very highly concentrated in people living with type 1.
Thank you. And if people eat a very healthy diet, for the most part, eating like, a raw food diet of sprouts, green vegetables, green juices, and their blood sugars at the optimal level, is it okay if they eat some oils? And I think you said seeds were and nuts were, and avocado and olives are kind of a yellow, but like oil, is that okay?
Yeah. Okay. So I'm going to put oil in the no category. And I know that oil has become a very contentious food, and there's intense rivalries online about whether oil is okay or not okay. The reason I'm going to put oil in the no category, if you take a look at the screen here, is you'll see oils right here. It says oils of any kind: olive oil, coconut oil, canola oil, avocado oil, walnut oil, MCT oil, you name it, any kind of oil. We put it in the red light category specifically. And the reason is because what the research shows is that oil can be part of a quote unquote healthy whole food plant-based diet for non-diseased individuals. But for individuals who are living with a pre-existing chronic condition, including either heart disease or diabetes, adding oil to your diet you have to be much, much more selective about how much oil goes into your food. And what we have found empirically is that small amounts of oil, people are like, oh man, I don't even use that much. I just use like a tablespoon per day, and I coat my vegetables with it. And that's what allows them to taste good. And even something as small as 1 tablespoon per day can add a significant number of calories, which can make weight loss challenging, but it still causes significant blood glucose irregularity. So what we say is that if you're living with a blood glucose irregularity, aka type 1 prediabetes or type 2, then my recommendation is cut out oil. Just be done with it. Okay. And you don't have to do it overnight. Again, ramp it down over the course of time and get to a point where your future self doesn't use oil. And if it happens to be present in your food every once in a while, don't worry about that, but try not to add oil to your food. And that is going to be a significant it's going to be a tool in your toolbox that will have a significant and immediate impact on your blood glucose control.
Okay, awesome. And does eating your diet, this diet, just a whole food plant-based diet as you laid it out, does that prevent all of the corollary diseases that you showed when you showed that circle?
Yeah.
Does that prevent all of them? You wouldn't expect to go blind, to get renal failure, heart disease?
Yeah. Okay. So let me put that slide on the screen one more time. So this way of eating, I have to be careful about the words I choose. If I say eating this way is going to completely prevent all of these conditions, I would be lying to you. Mm-hmm. And the reason I say that is because eating a whole food plant-based diet that is low in fat that comes from whole foods is going to significantly reduce your risk for the development of all of these conditions. Will your risk go to 0? It may not. It depends on so many variables. It depends on many other aspects of your lifestyle, right? How much alcohol do you drink? Do you smoke cigarettes? What is the stress level in your daily life? Do you exercise? If so, how much? What type of exercise? And the list goes on, right? But eating this way is one of the most effective tools that you have in your toolbox to effectively quiet down or reduce your risk for all of the conditions that you see on the screen here. The only one condition that I would say you can't really reduce your risk of, I'd say 3 conditions actually, is type 1 and 1.5 diabetes, because again, those are not those pre-exist before you transition to this type of diet. And then PCOS, because this is a congenital condition that women develop. But again, when you're living with PCOS, this can help reduce the symptomology of PCOS. But for the rest of the conditions here, it can significantly reduce your risk for your opportunity to develop them into the future.
And are there any reported cases of anyone ever reversing type 1 diabetes?
That's a great question. People who reverse, and so the answer is no. People who claim to have reversed type 1 diabetes don't have, they either did it in one of two scenarios. They either weren't living with type 1 diabetes, they thought they were, but they were living with type 1.5 diabetes, which is adult onset, slow progressing version of type 1 diabetes. Okay. And or basically still have some residual pancreatic function. That's what I'm trying to get at, right? So people with type 1 diabetes have zero insulin production, literally make zero insulin. But if you're living with type 1.5 diabetes, you don't have zero insulin production. You have some insulin production. You might have, 20% still remaining insulin production. As a result of that, you can eat a whole food plant-based diet and get to a point where you're like, oh my God, I have autoimmune diabetes and I don't need any insulin. But because you're still manufacturing insulin, you're technically not a type 1. Let's just put it that way.
Right.
And then secondarily, the other type of people are basically people who are newly diagnosed with type 1 diabetes and catch it like right off the bat. Those are the only people that may be able to stand a chance at like reversing the entire pathology, even though I haven't read about those people, I haven't met them. But I think that it is potentially possible for those people to completely reverse type 1.
Thank you. All right, I'm going to throw some questions from the audience here.
Sure.
Nancy, where are you from, and what is your question?
Hi, I have a question. So my doctor told me not to eat potatoes or sweet potatoes. So that's, I believe, I'm borderlining pre-diabetes to type 2 diabetes. I've been teetering it now with it for 2 years. So I really haven't got my hands around it, honestly, with respect to my diet. But
Sure.
This conference has, hopefully brought out the best in me. So my question is, it says that you think that starchy vegetables are okay, but she said not okay. So what should I do? Because I really like sweet potatoes, and I could make that a good piece of my diet if it's something that I should be doing. What do you recommend?
Yeah, my answer to you is potatoes are in the green light category. So again, if you avoid eating potatoes, then effectively the reason why doctors believe that is the right scenario is because they are operating in the old world, which says potatoes contain carbohydrate metabolizes sugar, and that's a bad thing. Okay. Potatoes contain whole carbohydrate material, and the only way to be able to effectively metabolize potatoes and other carbohydrate rich foods like fruits and legumes and whole grains is if your fat content is between 10 and 15% of total calories. So my suggestion to you is don't focus on the potato, focus on the fat rich foods in your diet. If oil is in your diet, get it down. If there's a lot of avocado in your diet, get it down. If there's red meat, white meat, chicken, fish, other fat rich foods, get them down. Once you do that, your carbohydrate tolerance increases significantly. Your ability to metabolize white potatoes, purple potatoes, black potatoes, sweet potatoes, anything you want goes significantly up, and your blood glucose is going to be very well controlled. Does that make sense?
Yeah. Yep. Thanks.
Cool.
All right. And how long does it take usually for someone who is following the protocol that you laid out to reverse their insulin resistance?
It's a good question. So I'm going to say a minimum of like 3 months and a maximum of about 2 years. Okay. And it depends on the number of factors. The people who can do it in 3 months are people who are like super dedicated to the process and already have many other aspects of their lifestyle, hammered out. These are the type of people that can act quickly, and they can basically not only transition to a whole food plant-based diet that's low in fat, but also exercise regularly and also perform some intermittent fasting either on a daily or weekly basis, and also eliminate alcohol or significantly reduce alcohol consumption, and also live in a low stress environment. If you can execute all of that and you can be very consistent about that, then expect it could take you as little as 3 months, maybe 6 months. But for other people who, maybe they have a significant amount of weight to lose, they have to lose 40, 50, 60, 100, 150 pounds. Maybe they're sedentary, maybe they drink a little bit of alcohol. et cetera, et cetera. For those individuals, we have to extend the timeline to maybe close to 9 months, a year and a half. But both of them require very consistent behavior. And if you can be very consistent in your behavior, then you're going to stand the greatest chance of keeping that timeline as small as possible.
Okay, next question is going to Roger. Where are you from and what is your question?
Roger Test.
Roger, you have a serious echo going on there. If you can shut off, maybe you're listening to two devices.
Okay, I shut it off.
There you go.
I didn't know that was going to happen. Roger Test, Cokeville, Wyoming. Cyrus, what to you is the most convincing evidence that insulin resistance is caused by fat in the cells?
Great question. There were papers that were written by an individual, his researcher, his name is Jared Shulman. He's out of Yale University. I saw him talk when I was at graduate school, and he is one of the most prolific researchers in this world of insulin resistance. He's written countless articles on this subject, and him and his research team have dissected in grave detail the actual mechanism of insulin resistance inside of humans. They show it inside of liver cells. They show it inside of muscle. And they were the first ones that opened my eyes to the actual mechanism that I showed you earlier, right? And there's actually like more complexity that we can get into. But the idea here is that saturated fat gets inside of a cellular environment. It then gives rise to other lipid metabolites. One of them are called ceramides. Those go and they dock on the intracellular domain of the insulin receptor, cause the insulin receptor to become less functional. Then insulin tries to bind on the outside, can't do it. So they've dissected this pathway in grave detail. And then there are other research groups that have built upon their research and shown it over and over and over and over and over and over and over again. And one of the reasons why it's so convincing is because, number one, the mechanism is very systematic, and like I've gone through the research process many times over, and to see just how exquisite they are in their research abilities and how detailed they are is just mind-boggling. And in addition to that, one of the things that makes good science is its ability to be replicated. So good science basically means you can perform an experiment, you can be very detailed with exactly what you did and give everybody the answer key and say, hey, look, this is exactly how we got this response. And then somebody else can go try and replicate it. If they can get the response, and then another group does, and then another group does, and another group does, that means it's likely to be true. And you didn't just make up your original research. So the fact that it's repeatable, and the fact that so many other research groups around the world who are very good at studying the molecular mechanism of insulin resistance have replicated their work leads me to believe that there's no reason to doubt that it's right. Does that answer your question?
He muted himself, so
Okay.
but it answered it for me. So another question for you is, what would be an indication for someone who has type 1 diabetes that they are now insulin resistant?
Good question. So if you're living with type 1 diabetes and you're insulin resistant, there could be many different symptoms of that. Number one, your ability to consume carbohydrates is very low. In other words, if you eat one fruit, your blood glucose goes quite high and you have to inject a lot of insulin. If you eat 2 fruits, if you eat 3 fruits, if you're eating small amounts of carbohydrate that are, on the order of anywhere from like 25 to 75 grams of carbohydrate, and you have to inject 5 units, 6 units, 7 units, 10 units, 15 units, and your blood glucose is doing some very strange things in the process, that's a very strong indicator that your actual carbohydrate tolerance is low. And every time you eat those foods, you're overwhelming your muscle and liver with the ability to metabolize that glucose. And that's requiring a lot of insulin. So that's my number one indicator for you. But number two, low energy is always a really strong indicator of insulin resistance because people report that left and right. And then number 3 would be effectively, you can measure your carbohydrate to insulin ratio. So if you did the same calculation that I did earlier, where I said the total amount of carbohydrate that I eat per day is blank, and the total amount of insulin that I use per day is blank, and you just do some simple math and you divide the two numbers by one another, if that number that you end up with is something less than about 10 to 1, then you're likely living in an insulin resistant state. So just for clarification here, on a previous low carbohydrate diet, I was 125 total grams divided by 42 units of insulin. So 125 divided by 42 is approximately 3-to-1. So this right here is an indicator that I'm in an insulin resistant state because it's less than 10-to-1. When I switched over here and I went 650 divided by 24, now I'm into 27-to-1 category. This is a significantly larger number, greater than 10-to-1. And that right there indicates that I'm in the insulin sensitive zone. So do this calculation for yourself and figure out what your number is. If you're below 10, treat it. If you're above 10, still treat it, but at least you give yourself some baseline indicators.
Okay, our next question is coming from Marley. Marley, where are you from and what is your question?
Hi, Cyrus. Hi, everyone. I'm from South Florida, Hollywood, Florida. So excited
Cool.
to see you here, Cyrus. I follow you. I have a lot of questions, but I'm only going to ask you like one. I have so many. Acai, you mentioned it. I love acai, and maple syrup I use for dressings. How do you feel about those in the green zone?
Okay. Acai, I eat acai every single day. So I'm in the same boat as you. I love it. There's not all acai is created equal. A lot of the acai packets contain like added sugar inside of them. So just be a detective and read the actual back of the package. And if you find sugar in it, then try and find one that's sugar-free. But I think your question was, you add maple syrup as a dressing, meaning like on top of the bowl or inside?
No, like when I make a dressing, like I follow the Esselsteins and they make a lot of dressings with like a tablespoon with a couple of vinegar and something else or strawberries in it. So I use like a tablespoon mixed with other ingredients to make a salad dressing per se, and then I put it over the salad dressing.
Got it. Okay, cool. So I'm not gonna come down on you and say, oh, you should never do that, right? If you're doing that and it's working for you and your blood glucose is relatively well controlled, then change nothing. Okay. The indicator that maybe, that amount of maple syrup is too much or it's causing blood glucose problems do you check your blood glucose on a daily?
I don't. I'm pretty healthy and I don't have any medical conditions. I'm 53 and my BMI is like 19, 20. So I'm pretty healthy.
Okay. And are you eating a whole food plant-based diet?
I would say about 90 to 95%.
Okay. And do you happen to know what your fat content is in general?
No, I don't.
No. Okay.
I exercise, but I don't know the actual fat content.
Okay. So for you and for anyone else who's interested in learning that information, download an app. It's called Chronometer, Chronometer. It's an exceptional app and it allows you to log your food intake. And you can say, I had 3 bananas here, and I had 1 bowl of oatmeal here, and I had an acai packet here, and so on and so forth. You just put all your food in, and then it'll do the math for you in the background. And it'll basically say, okay, great. Marley, you had this many grams of carbohydrate, this many grams of fat, this many grams of protein, and it kind of gives you the breakdown. Yeah. What I want you to pay attention to is put all your food in there for like a 3-day period. And what you're looking for is your total fat content to be less than 30 grams of fat per day. That's the sort of like magic threshold.
Yes.
You can keep your fat intake to less than 30 grams of fat per day. Then I will allow you to put maple syrup into your food.
Okay.
If your fat content is greater than 30, then maple syrup could cause problems down the road. Just a simple.
Okay. Thank you. Thank you so much.
And can you say that app one more time? Someone's asking in the chat.
Yeah, sure. It's called Chronometer, Chronometer.
All right. Perfect. Thank you. Okay. Our next question is going to come from Anatina. Please tell us where you're from and ask.
Thank you. I'm from New York. First of all, thank you, Cyrus, for your outstanding, clear presentation and your beautiful, inspiring attitude.
Awesome. Thank you.
The beautiful smile helps too. I have 2 little questions. One is, has anybody studied if slaughterhouse workers and their families have higher incidence of type 1 diabetes?
Oh, that's a great, it could exist, but I have not read it. So that's a great question.
And the other question, what became of your Hashimoto's?
What became of Hashimoto's? Good question. My Hashimoto's basically got to a point where the way that I measure my, the severity of Hashimoto's is based off of how much thyroid hormone I have to take on a daily basis. So my thyroid hormone was creeping up from 37.5 micrograms to 62 to 75 to 115 to all the way upwards of 150 micrograms per day. That's where it peaked.
Uh-huh.
And then from that point, it has actually come down to 112 and then stabilized at 125. So my response to you is, I wish I had caught Hashimoto's earlier, because then I would have potentially standed a chance of actually reversing it. I can't say that I've made significant progress in it. I've just prevented it from getting any worse than it was. Let me put it this way. It was accelerating very quickly at the beginning of the disease process. I've arrested that progression and brought it down just a little bit.
Okay, thank you.
For sure. Do you have Hashimoto's as well, by any chance?
No, I don't have anything.
Good. Let's keep it that way.
All right, very proactive audience. So I want to thank you. We've come to the end of our Q&A. So thank you so much for all the amazing information. If we can unmute the audience, please.
Thank you.
Thank you.
Thank you so much.
Thank you, Sam.